In this video, we'll be going through the base configuration of a Cisco router. The scenario is that we just got our router from Cisco, we've purchased it, it's fresh out of the box. Now we have to add it to our network and start to configure features on it so that it can actually do something. Now before we configure any advanced features like IP routing or NAT or DHCP, we need to put some base configuration on the router. A, to get it up and running, and B, so that we can add some security to it and we can access it remotely instead of having to have a constant connection. Part of the base configuration is to configure a device for Telnet or SSH access so that we can now access the device remotely. Now, let's talk about the need for base configuration. So unlike a switch, a Cisco router out the box will not do its job. So a Cisco router actually needs base configuration on it so that it can do something. So with Cisco switches out the box, devices in the same network, if we connect them to a Cisco switch, a switch which has got no base configuration on it, the switch will actually do its job and switch packets between those hosts. Now with a router's job is to get itself on network onto another broadcast domain, another network. As an example, it could be a connection to the ISP or a connection to another enterprise site. With a router, by default, it will not be able to do its job unless we put some base configuration on the router itself. And by putting base configuration on the router, add security to it, and it gets up and working. And the base configuration for a Cisco router is exactly the same as the base configuration for a Cisco switch. So we'll be configuring the console password, login banners, enable secret password, hostname, IP address on the interfaces, all that sort of things. So I'm going to pause the video very quickly and I'll bring back a console connection to a Cisco router. Welcome back. So I've got a console connection to this router, and the network I've got set up is a very small network. All it is just a router which we're going to put the base configuration on, and off one of its interfaces it is connected to a switch. So the reason why I've done this is for the demonstration purposes of this video. The first thing we're going to do would be to configure a host name for the router, and we configure the host name in global configuration mode, which is the same as with a switch. So we're in privilege mode, we move into privilege exec mode with enable command. Then from privilege exec we move into global configuration mode with the configure terminal command. Once we've used the configure terminal command to change the host name of the router, we use the command host name, and then we can set the host name. So in this case, I'm going to configure the host name as R1. Now that we've configured the host name, let's secure the console line. So by default, I've got a console connection to the device. By default, Cisco device will only accept a console connection for configuration purposes. We can configure remote access via the VTY lines. But by default, the console has got no security on it. So as an example, I'm got a console connection. I can access the the router without having to enter any password or without having to do anything. So obviously that poses a security risk to the system. So what I'm going to do, I'm going to lock the console line down by configuring a password for it. So to do this, we enter line console configuration mode, so line console 0, and we just use the command login, and then we use the command password to set the password. So in this case, this tells the router that when someone tries to access you via the console, prompt him for a login, and this is saying that this is the password that you prompt them for, and this is a case sensitive password. So exactly how I've entered it, exactly how I've configured the password, that's how we have to enter the password when we have a console connection. Just to show this in action, now when I try to access the console, it prompts me for a password. I've entered the password of Cisco. Let's move back into global configuration mode. And so also whilst in the line console mode, we're going to configure logging synchronous. All this does is tell the router that when you issue a system message on the screen, instead of leaving my prompt hanging off the end of the system message, bring my prompt to a new line. It just makes it easier to basically to configure the device without having system messages interrupt you whilst you're doing it. The next thing we're going to configure is exec timeout. So with exec timeout, if this is a lab switch, we would normally configure to 00, which means don't timeout. This is saying that if someone has a console connection to the device and they're idle for a certain amount of time, then log them out of the Cisco device. So if let's say I set this to 5 minutes. If I was idle for 5 minutes and didn't do any configuration on the router, I'd be booted out of the device, and I'd have to access it again by entering the password. So I'll be booted out, then I'll have to log in again, basically. And once we've done that, we're going to configure the enable secret. To do this, we use the command enable secret. In this case, it's going to be Cisco. And we can configure an enable password as well. Cisco. So if I go to the show running config command, this shows you the current running configuration on the router. So what you can do as you're configuring the router, you can issue this command to see the commands you've entered before you save the configuration. As you can see, it stores the enable secret in the enable secret command in the hash format, but it saves it. It stores the enable password in clear text. Now what we can actually do, we can actually tell the device, whether it be a router or a switch, to store the enable password in a encrypted format. So to do this, we use the service password encryption command. If I issue the show running config command again, just takes a second, the router is quite slow. And as you can see, routers are software based and switches are hardware based, and you can see that with the router, it's a lot more slower than my switches. With the switch, everything was done instantly. With the router, it's taking a bit of time. But as you can see, it's actually stored the enable password in a encrypted format. So that now when someone's walking past, they won't be able to see what the enable password is. Problem with this type of encryption is very, very weak. It can easily be broken. And so normally service password encryption is normally used to protect against line of sight. So by line of sight, I mean if someone's walking behind you and then they see the running configuration, at a glance they wouldn't be able to tell what the enable password is. Now if somebody was actually able to access your device and get hold of this number, they could literally just go to a website, copy and paste this in, and then they would have the actual clear text format of the enable password. So this service password encryption doesn't provide good security for passwords. It's just to protect against line of sight. Now that we've configured the enable password and enable secrets, let's configure the Cisco device for remote access. So to configure a router for remote access, it's the same as how we configure a switch for remote access. We go to the VTY lines, in this case VTY line 0 to 4, and we use the command first we set the password to Cisco, then we use the command login. So with the login command, again it tells the router that when someone tries, in this case, when someone tries to accesses you remotely via Telnet, prompt that person for a password. And this is the password value that we expect them to enter. And again, it's case sensitive, so we can't have a capital C or a capital I. It has exactly how I've configured the password here. That's how they have to enter it. And now let's configure our login banners. So in this case, banner. So we've got our different login banners. We've got the MOTD banner, the exact banner, and the login banner. So let me configure my exact banner first. Again, we begin with our delimiting character. This is the exact banner. And we have to end with the delimiting character. Then we use the command banner login to configure the login banner. The delimiting character can be any character on the keyboard. The way it works is that the character that we begin the message with, to signify the end of the message, we have to end our message with that character as well. This character isn't displayed on the actual banner itself. This is the login banner. End with the hash sign. Now we're going to configure the message of the day banner. This is the MOTD banner. As you can see, the delimiting character doesn't actually matter. in every single one of these example configurations, I've used a different delimiting character. It could be any character on the keyboard, as long as we begin and end the message with that same character. If I exit out of here, press enter, as you can see, the message of the day banner and the login banner are displayed first, and only once we have access to privilege mode is the exact banner displayed to the person who's configuring the device. Now once we've done that, we need to configure an IP address on the router so that it has IP connectivity and has a connection to our network. So by configuring an IP address, it means that we can communicate with that device. It's been assigned an IP address, and it can send and receive traffic. Now with a switch, a layer 2 switch, all ports are in the same broadcast domain. So with a switch, we would configure the IP address. It would just have one IP address, a layer 2 switch, which would go on what we call the VLAN interface. With a router is slightly different. If I use the show IP interface brief command, each IP address is in its own broadcast domain. So the IP address we have to configure would go underneath the interface. And so the way it would work, in my example, I have a connection to a switch. The switch connects to interface fast Ethernet 0/0 on my router. So I'd have to configure an IP address on the router underneath fast Ethernet 0/0, and that IP address would have to be an IP address that is would have to be a usable IP address from the subnet that has been assigned to the segment. If I had a connection to, let's say, an ISP, then what would normally happen is that I would use the IP address I would use a usable IP address for the subnet assigned to the segment over here. Or what normally happens when you have a connection to the ISP, they use DHCP to automatically assign you a global IP address. So each interface on the router needs an IP address, and so to configure the router with an IP address, so it can actually start to receive packets and can actually start to send and receive traffic, we go into global configuration mode, go into interface, the correct interface, in this case interface fast Ethernet 0/0. We use the command IP address, in case 192.168.1.1, configure with a subnet mask, and that still isn't enough. As you can see, by default the interface is shut down. So with a switch, the interface won't shut down. The reason why with a switch the interfaces were shut down was because there was no device connected to the other end of that port, so the port was down. However, as soon as you connect a device to that port, the port comes up. With a router it's different. By default, the ports are administratively shut down, which means that even if you do connect a device to the router, the port won't come up. This is why it's so important that we have some base configuration on the switch, because we would have to, at the very minimum, configure an IP address on the router, and then bring up the interface by using the no shutdown command. So if we use a show IP interface brief command, now the interface has an IP address and is moving to the up state. So the interface on the router is the up and up. The router is now able to send and receive traffic, and if I was to ping the router from my laptop, it would respond back. So we have reached the end of this video. This video was a very quick video because we already run over the base configuration on the Cisco switch, and on a Cisco router the base configuration is almost identical. I hope this has been informative for you, and I'd like to thank you for viewing.